We'll be discussing about the timers now. So as in screen you can see like basic instructions. Just below that you can see like the timer operations. Inside the timer operations you can see like multiple types of timer. The first one that we are going to discuss is like T on, like on delay timer. So I'll be just clicking and dragging that to the ladder. So inside the ladder I'll be choosing the default timer address. So timer is being provided. Now in order to turn on the timer I'll be using like a start switch, so which helps you to turn on the timer. And as you can see like here PT is mentioned. PT is like preset time, which helps you to predefine the total time to which the timer should work, and it have a particular time syntax, and that is like T hash and then how many seconds. So imagine I'm just giving like a 5 seconds, so it will be like 5s. So first rung is completed, and for the second rung I will be giving a particular output, and right now my output is like a conveyor belt, so I'll be using like a conveyor output address, and we need to turn on the conveyor after a particular delay. So I have to use the timer bit here, so it comes as a contact, like an NO contact with the timer address. So here you have the timer with the Q as the timer done address. Now as we all know, like we have to download the program and just start the monitoring. So we have to load the program to the controller. Once the loading is completed, we'll be moving to the monitoring section. And once the monitoring is started, we'll be just turning on the input, so that you can see as in the screen the timer is working, and after the particular delay of like 5 seconds, the conveyor 1 will be enabled. The next type timer is like timer accumulator, or else you can have like a synonym name is like a timer retentive. So I already placed on the ladder. I'll just turn on the monitoring as I already downloaded the program for you. So once the monitoring has been turned on, if I turn on the input, like so you can see like input is there, you have a new option called as R, which is like reset option, and the preset and the timer address as the same. So what I'm going to do is like I'll be turning on the conveyor using the T on R, like on delay retentive timer. So we need an input, so I'll be just turning on the input. So you can see as the timer is working right now. In between, if I turn off the switch or the power supply to the timer, it retains its position. It will be stopped at that position. And if I turn on the same switch, the start switch again, it starts from that point, same as like the washing machine application. And then it will complete its total preset time, and then you'll get the output. Now there is a problem, like not the problem, like the specialty of the timer is like if you turn off the start switch, the timer will not go back to the initial position. That's the main difference between on delay timer and on delay retentive timer. So in order to do that, you have to reset the timer. For that we have an option called as R, that is reset or the stop switch. So I'll be just turning on that switch, timer back to the initial position. So the next is like off delay timer. So off delay timer, it has a specialty that when you turn on the switch, at the same time the timer gets activated, like timer gets the power supply, and you'll get the done bit activated, so that the output will be turned on. But as you can see, like the timer is not working, its accumulation, like the current value is still 0. So if you want to give the delay, as the name suggests you, it is off delay. So whenever you turn off the switch, at that time the timer will give you the delay. So when you turn off the switch, the timer gives you the delay. During the delay, even the output will be on, and after the completion of the delay, output will be turned off. Next is pulse timer. So pulse timer is a timer which helps the timer to active if you give a pulse. So it can be like the application of your push button. So if you press and release the push button, doesn't matter, the timer works. And timer works, and during the delay you got the conveyor belt on, and after the delay, like after the working of the timer, that pulse is completely gone off, so the output will be turned off. And one more specialty is that while the timer is working with the initial pulse, even if you try to turn on again, it doesn't work. So that's the application of the pulse timer. Next concept is counter concept. So here we have like 3 different types of counters. So I'm going to give you the complicated counter, as you know, like up down counter. So I already placed the counter with its corresponding inputs and outputs. So these are the different types of input sections that you can find in your counter. So CU means up counting sensor, CD is like down counting sensor, R is like a reset option, LD is like a load option, PV is like preset value, so which the maximum count that you want the counter to perform, and QD is helping you to turn on an output, when the counter reaches its maximum preset value. QD is like an output which helps you to analyze, or which helps you to turn on when the counter is at its minimum value. So I already downloaded the program. So once I'm turning on the switch, on turning on the monitoring option, so here you can see like multiple inputs as I mentioned before. So right now the counter is having the current value as 0. So I'll be using like a CU switch to up count the counter. 1, 2, 3, 4, 5. So up out is been enabled. Now I'll come back with a CD like down counting. So imagine that you have a conveyor belt to which a particular count is being uploaded. Now I'm taking it out. So the components are coming out. 1, 2, 3. So you can see like the current count is coming down, like decrementing. Once it reaches 0, so 0 is the minimum value. So you can see like that down count out is being activated. Now load is like, imagine that you have a inspection or something like that of like 500 components, and you will be inspecting like first 50, like random 50s, and then you can give the load command. So right now the count is 2. So if I enable like the load, it is going to be like the maximum count. And R like reset. So if you turn on the reset option, the count will be back to the 0, like the initial count. So that is how the up down counter works. Next concept is compare functions. As you can see on the screen, like you have the comparator operations. Below that you can see like multiple compare functions like equal to, not equal to, greater than or equal to, greater than, less than or equal to, less than, all those functions. Right now I'm using like less than function. So I already downloaded the program for you. Now if I turn on the monitoring, you can see like both MW0, that is like an integer register which we use in the Siemens PLC with the TIA Portal as a programming software. So it's like a memory word with a 0 register. Like this is like memory word with a second register. So both are having like initial values like 0. So if you go to the watch table, there you can see like MW0, MW2, both are having like 0 as the value. I'll be giving like the second register like a high value. If I give a high value, and then if I forcefully write the value to the MW2, you can see like the value has been monitored, like the change of value has been available here. And when you move to the programming ladder, there you can see like, so the value inside MW0 is less than the value inside MW2, which is like 0 and 5. So 5 is obviously greater than 0. So the command or the instruction satisfies. That's the reason you're getting the out. And this is how the compare function works. Next is math function. So inside the math function, there are multiple functions like addition, subtraction, multiplication, division, mode, negate, all those functions. So I'll be showing you the add function. So I already provide the add block here with the 3 different kind of registers. So you can see like in1, in2, and out. So these are the 2 different input registers to which you can feed the values, and they will get like a summation. They'll do the summation and you will get the result on MW4. So once the downloading and the monitoring has been done, you can move to the watch table to provide the values for MW0 and MW5. So I'll be giving like a small random values like 2 and 5. Then I have to just write the values to these particular registers. So your input registers will be having those 2. And of course you can see like the result on MW4 here. We'll check on the ladder as well whether the answer has been came or not. Yeah, so you can see like the final answer has been out. So this is how you will be giving you will be providing the different kinds of input numbers to the block. And imagine if you're having like an input switch here, then you have to control the block using that input switch as well. The next instruction is jump command. You can find them on program control operations. Jump and label will take them together to the ladder program. As I already downloaded the program, we'll be just moving to the monitoring section. I'll give you a live scenario. Imagine that as you can see on your ladder diagram, the motor 1 is not working. Imagine you're having a condition that motor 1 is not working, so the technician is being called out. So during the time period when the technician resolves the problem that is connected with the motor 1, we don't need that particular line to perform, right? So what I do is like I'll just turn on the jump command. So you can see like jump is having a label that is A1, and the same label is being provided for the outside like jump label command as well. Both are identical. So your second network will not be working. So which means basically like in between the functions like jump start and jump end. So the functions that already been given in between the jump start and jump end command will be deactivated for the time period. So if I turn on second switch, still the motor 1 will not get activated. But as I mentioned, like A1, the label A1 is like the end process of your jump command. So third input on, yeah, motor 2 will be working. Now you might arise a question, so okay, how can I turn on my motor 1? It's very simple. Just turn off your jump command. Then if you turn on your switch which is corresponded to your motor 1, it will trigger and your motor 1 will be activated. So that is basically like a jump command. So if you're having some scenario that you don't want a particular run to work, rather than deleting the run and doing it one more time. Next instruction is function call, or like call to subroutine or jump to subroutine. You can call them any of these names. For that we need like two different ladders. So as you can see, this is going to be like a main program. So it's like a OB1, like that is like organization block 1. So here we'll be just providing one input so that the input can call your function. Now we have to create a new function block. So once you click on add new block, you have these many options. Inside that you'll be clicking on the function, or like basically it's like a function call option. So just click on OK. So here you can see like a new ladder is been activated or been generated, that is FC1. So in FC1 we'll be giving our backup program or like a secondary program with, I'm giving it like basic input and output. Now this network has been satisfied, like completed. Now what we have to do is like we have to go back to your OB1, that is your main block, and you have to call your function block. It's very simple. Just click and drag that function to your main ladder. So you can see like enable FC1 with this particular switch. Now I'm going to download the program. Once the downloading is completed, we'll be just starting the monitoring option. And for splitting the screen, I'll be using like a horizontal option. So you can see like a, oh yeah, horizontal doesn't work, I think. So we'll be moving to the vertical option. So you can see like two different ladders together. So this is your main program and this is your sub program. I'll just start the monitoring of your sub program as well. So it is very easy for us to identify. See, as you can see, like the function call is not been activated at the moment. So what we have to do is like we have to just, I'm going to try it actually. If I turn on the second input, nothing happens, so your output will not be working. So what we have to do is like we have to enable FC1 using your first input. Now you can see the change. This block has been activated. So if you turn on your second input, the output will be working. So this is going to be like a function call option. So it's like a backup program. So the main program will be working as normal, but if you want to call a secondary program or something like that, you can use this option as well. So that's about the instructions that we will be seeing in this particular video. Thank you.